A quiet revolution is unfolding in the world of science and technology, one that could redefine how we power our lives. It begins with something so simple, so ordinary, that most of us never even notice it. Magnets. They are the silent, invisible force behind nearly every modern convenience we take for granted. From the hum of your refrigerator to the buzz of your smartphone, magnets are working tirelessly behind the scenes. Yet for all their importance, they've remained largely unchanged for decades, until now. A groundbreaking invention first conceived in a university lab is challenging everything we thought we knew about magnetic power. This isn't just an upgrade, it's a leap into uncharted territory. Imagine magnets 10 times stronger than anything we've ever seen. Imagine machines that were once dismissed as impossible suddenly springing to life. This is the story of that revolution. It's the story of how a small team of researchers dared to rethink the impossible. And it's the story of what happens when science finally catches up to the dreams of inventors long forgotten. The world runs on magnets, though few realize just how deeply they shape our daily existence. Every flip of a light switch, every turn of a car engine, every click of a computer relies on their unseen force. They are the unsung heroes of modern technology, hidden in plain sight. But even heroes have limits. Traditional magnets, even the strongest rare earth varieties, eventually weaken, fade, or fail. They hit a ceiling, one that has stalled progress for generations. That ceiling is about to shatter. A new kind of magnet is emerging, one that doesn't rely on scarce materials or fragile supply chains. It's stronger, lighter, and more efficient than anything before it. And it's poised to unlock technologies that were once relegated to the fringes of science. This is where the story takes an unexpected turn. Because some of those fringe ideas weren't wrong, they were just ahead of their time. Inventors like Joseph Newman, Howard Johnson, and John Bedini spent their lives chasing machines that defied conventional physics. Their designs were mocked, dismissed, or ignored. But what if they weren't failures? What if the only thing standing in their way was the lack of a magnet powerful enough to bring their visions to life? That's the question now being revisited. With this new generation of supermagnets, forgotten blueprints are being pulled from drawers. Old experiments are being re-examined. And the line between fantasy and reality is blurring. The implications are staggering. We could be on the verge of a new era in energy, one that doesn't rely on fossil fuels, one that doesn't pollute, one that doesn't drain finite resources. But first, we have to confront a difficult truth. Science has a long history of dismissing what it doesn't understand. The road ahead won't be easy. Skepticism will linger, failures will happen, yet the potential is too great to ignore. This isn't just about better gadgets or faster motors, it's about rewriting the rules of what's possible, and it all starts with a magnet. The whispers of change began in a quiet lab at the University of Minnesota. No fanfare, no grand announcements, just a team of researchers working tirelessly on what seemed like a simple problem. How do you make a magnet stronger? The answer, it turned out, wasn't in mining deeper or refining further. It was in reinventing the material itself. Their breakthrough came in the form of iron nitride, a compound that defied expectations. Unlike traditional magnets, which rely on rare earth elements, this new material was abundant, stable, and astonishingly powerful. It wasn't just an improvement, it was a revolution in a tiny, unassuming package. The company behind it, Newman Magnetics, didn't set out to change the world. They set out to solve a puzzle. But in doing so, they may have unlocked the door to a future we've only dreamed of. Suddenly, machines that once struggled to turn could spin with effortless precision, and motors that guzzled energy could run with near-perfect efficiency, and those long-dismissed free energy devices, they deserved a second look. Take the Newman motor, for example. Joseph Newman's controversial invention was once written off as a violation of physics. But what if the real violation was assuming his magnets were good enough to prove his theory? With Newman's supermagnets, the equation changes. The same motor, rebuilt with modern materials, could finally deliver on its promise. Then there's Howard Johnson's magnetic propulsion system, a machine that ran on nothing but arranged magnets, pushing and pulling in perfect sequence. It worked, just not well enough to matter. Now, with magnets 10 times stronger, the flaws in his design might finally be overcome. And what of John Bedini's pulse motor? A device that seemed to recycle energy with uncanny efficiency. Skeptics called it a trick. But what if the trick was using magnets? That couldn't keep up with the idea? Upgrade the magnets and suddenly the entire system becomes something entirely new. Even the most enigmatic devices like the Searl affect generator enter the conversation. A machine that allegedly defied gravity, floating as it generated power. Dismissed as myth, it was never tested with materials like these. Now it might finally get its fair trial. The common thread in all these stories isn't delusion, it's limitation. These inventors weren't wrong about magnetism's potential, they were wrong about how soon that potential could be realized. Now, the timeline has caught up, but this isn't just about revisiting the past, it's about building the future. Imagine wind turbines with lighter, more powerful generators, electric cars with motors half the size and twice the efficiency, medical devices with precision never before possible. The applications are endless, yet the greatest impact might be on energy itself. For too long, we've relied on burning, drilling, and consuming. What if the next great leap wasn't in how we extract energy, but in how we harness the forces already around us? That's the promise of supermagnets. They don't create energy, they amplify our ability to use it. The skeptics will remain, and rightly so. Extraordinary claims require extraordinary evidence, but for the first time in history, we have the tools to test those claims properly. No more excuses, no more dismissals, just science done right. This is more than a technological shift, it's a cultural one. We're standing at a crossroads between the science we know and the science we've yet to discover. The path forward isn't clear, but it's undeniably exciting. And it's not just for researchers in labs, it's for tinkerers in garages, students in classrooms, visionaries everywhere. The next great breakthrough might come from someone you've never heard of, someone armed with nothing but curiosity and a magnet strong enough to change the world. The future isn't written yet, but one thing is certain, it will be magnetic. The story of magnets is far from over. In fact, it may just be entering its most thrilling chapter. What began as a quiet breakthrough in a university lab has ignited a conversation that stretches across science, industry, and imagination. This isn't just about a new material, it's about rewriting the rules of what's possible. For too long, we've accepted the limits of our tools as the limits of reality. But history has shown us time and again that today's impossibility is tomorrow's inevitability. The skeptics will always have their place. Doubt is the counterbalance to discovery, the necessary friction that keeps progress honest. Yet there's a difference between healthy skepticism and closed-minded dismissal. Many of the greatest leaps in science were once ridiculed. Electricity, flight, even the concept of germs, all were met with laughter before they transformed the world. Could magnetism be the next frontier to follow that same arc? The answer lies not in blind belief, but in open-minded testing. What makes this moment unique is that we finally have the tools to explore ideas that were once beyond our reach. Neutron supermagnets aren't magic. They're the result of decades of incremental progress in material science, now reaching a tipping point, but their implications could feel almost magical. Imagine a world where energy isn't something we mine or burn, but something we harness from the invisible forces around us. That's not a fantasy, it's a question. of engineering. The inventions we've revisited, Newman's motor, Johnson's propulsion, Bedini's pulse circuits, weren't failures of imagination. They were failures of materials. Now, with stronger, more stable magnets, we can finally separate the flawed concepts from the misunderstood breakthroughs. Some will undoubtedly fall short. That's the nature of science. But others might surprise us, revealing efficiencies or phenomena we hadn't anticipated. That's where true innovation happens. Not in the safe center of accepted knowledge, but at the edges where curiosity meets uncertainty. The road ahead won't be easy. Old paradigms don't fade quietly. Industries built on fossil fuels, traditional manufacturing, and centralized power won't embrace disruption willingly. But disruption doesn't ask for permission. It arrives when the time is right, when the pieces finally align. And right now, the pieces are aligning in ways that should make us all pay attention. This isn't just about energy. It's about autonomy, resilience, and democratizing access to power, literally and figuratively. Imagine rural communities with self-sustaining magnetic generators. Imagine electric vehicles that charge themselves through motion. Imagine medical devices so efficient they never need battery changes. These aren't pipe dreams, they're engineering challenges waiting to be solved. The inventors of the past laid the groundwork. Their notebooks and prototypes are like time capsules waiting for the right key to unlock their full potential. That key might finally exist, but technology alone isn't enough. Visionaries need collaborators, theories need testing, ideas need funding and faith. That's where the next generation comes in. Students tinkering in garages, engineers questioning assumptions, scientists daring to revisit failed experiments, they're the ones who will push this forward. The role of established institutions will be crucial. Universities, corporations, and governments must create space for high-risk, high-reward research. Not every experiment will succeed, but the ones that do could change everything. This is how progress works, not in straight lines, but in leaps and stumbles. For those who've spent years dismissed as fringe or foolish, this moment is bittersweet. Recognition often comes too late for the pioneers, but their legacy lives on in every curious mind who picks up where they left off. That's the beautiful cycle of discovery. No idea truly dies if it's grounded in truth. It just waits for the world to catch up. Now, the practical questions remain. How do we scale these new magnets affordably? How do we integrate them into existing technologies? What unintended consequences might arise? These are problems to solve, not reasons to hesitate. Every transformative technology brings challenges. The Wright brothers didn't have perfect aerodynamics. The first computers filled entire rooms. Progress starts messy and refines over time. What matters is whether the core idea holds promise. In this case, the promise is undeniable. Stronger magnets mean more efficient machines. More efficient machines mean less wasted energy. Less wasted energy means a lighter footprint on our planet. That's a chain reaction worth pursuing. But let's be clear, this isn't a silver bullet. No single invention will solve all our energy needs. The future will be a patchwork of solutions, each playing its part. Supermagnets could be one of those critical pieces. Perhaps the most surprising thing about this story is how quietly it's unfolding. There are no flashy headlines, no billion-dollar IPOs, just steady, determined progress. In a way, that's fitting. Magnets have always worked in the background. Now they're stepping into the light. For the dreamers, the builders, the questioners, this is your moment. The tools are here. The ideas are waiting. The future is unwritten. What happens next is up to you. Will you dismiss the past as obsolete or mine it for overlooked wisdom? Will you see limits or possibilities? The choice is yours. But remember, every revolution starts with someone who believes the impossible is just a problem to be solved. This time, the solution might be simpler than we ever imagined. It might just be a magnet. A better magnet. a magnet strong enough to change the world, and that changes everything.